Okay, great. So it looks like this Hangout is now live on air. So welcome everybody. For the purpose of the recording, what I was just saying is that today on the call we're going to go through what the OpenHIM tool can do. So the OpenHIM tool is the reference implementation of the interoperability layer that we're using for OpenHIE, part of the OpenHIE community. So today I'm going to go through, we had a recent release of the OpenHIM, version 1.2, and what I'm going to go through today is just a general overview of some of the features and what you can expect, and the idea is to actually get down and actually show what the tool can do. And anyone who wants to ask questions, feel free to do so anytime, and we can just do this sort of informally, and feel free to ask questions as I go through things and whatever you like. So let me get my screen shared, and then we can dive in. Okay, so I've got my screen shared. Can everybody see that all right? Is that working fine? Take no objections as...
Yep, we can see it fine.
Okay. Okay, great. So this is the OpenHIM tool. This is the page that you'll see upon logging in, or upon being asked to log in. So I'm just going to log in right now, and then we'll go through some of the things that can actually be done. Okay, so I've just logged in, and this is what you're presented with. This is basically the web console of the OpenHIM tool. So the OpenHIM tool really works as two separate pieces. The one piece is the core, which is the server, which sort of does all the actual hard heavy lifting and all the processing. And the second piece is the administration console, and that's what we're looking at right now. So the administration console talks to the OpenHIM core through an API, but you don't actually have to have the console running to run the OpenHIM tool. It's just an easy tool to see what's going on, to configure it, and to see what's actually happening on the OpenHIM. So that's what we're looking at now. So the first thing we're presented with is the transaction log. So this shows all the previous messages that have traveled through the interoperability layer, and where they've been sent and what the status is. So you can see here we've got a few filters, and then a list of different transactions that have run through. Now you can filter by a whole bunch of different things. Status, so you can show just the transactions that have failed, the ones that are still processing, the ones that are completed, and some that are completed with errors and completed successfully. So, and then also you can filter by the channel that's the transaction relates to. So how the OpenHIM works is you have a number of different channels that you can set up, and that determines when messages get to the OpenHIM, it determines where those messages go. And we'll have a look at channels in a little bit. And then obviously just by date range and things like that. We also have a whole host of advanced filters that you can also search by. And these contain things like what client actually sent in that request. And when we talk about client here, we really mean what system. So what external system, maybe what EMR system, for example, sent in this request, and has this request been rerun, and various other things that you can want to filter by in a more advanced fashion. So those might start to make sense as we go through some of the other stuff. But I guess the real crux of the screen is actually showing these transactions. And if I click on one of them, what it does is it actually brings up this sort of screen that shows the status of the message, where the channel that came from, the clients that actually sent that message in, and then the actual request and response that was received from the OpenHIM tool. So you can see here we received a message on path /MHD. This is some of the testing I was doing earlier today. It was a post request, and there's all the content of the message. And this, we also can get to see all the HTTP headers and everything. So basically all the technical details that you need to see what was actually received by the OpenHIM. And then if you wanted to view the rest of the body in sort of a bigger screen format, which is often useful for extremely large messages, you can open that out as well. We also do have some syntax highlighting that happens in these boxes to make it easier to read. It doesn't work for this type of message, but in general, XML and JSON messages will be syntax highlighted just so that you can get an easy understanding of what's going on. And then if we switch across to the response tab, this is what the HIM has actually received back from wherever it sent the message, and what it's returned to the client that invoked the OpenHIM. So we can see here the syntax highlighting is working on this body, and we've got this is the response that we received back. So you can see, for example, here that we got an error back saying that this document was a duplicate, and this is just an xds.b message that I was testing with earlier. So that's the sort of stuff you can see here. Then you'll see there's also quite a special section in the response labeled Orchestrations. So what happens is with the OpenHIM tool, what we expect is that the OpenHIM really is able to receive requests and then send them on to other systems to do work, and then it just captures the response as well. But we also have a concept of mediators within the OpenHIM, and mediators are really separate little services that are able to do other work on the request. So for example, if you wanted to transform a request from say HL7 version 2 into a FIRE request, for example, you could do that in a mediator. You could also, if you wanted to do some other sort of more complex logic, for example, trying to resolve a person's enterprise identifier. Say you have a patient ID come in that's the local ID that's used at the EMR, and you want to resolve that to an enterprise ID that's used uniquely to identify that patient within the health information exchange. You could do that also within a mediator. So so here you can actually see there's a few different orchestration steps that happened, and these happened within a mediator that's attached to this channel that this message got sent to. So what the OpenHIM tool does is it actually makes these visible to you. So I won't go into those in too much depth now. Let's perhaps move on to some of the other pieces that might make this make a little bit more sense. So that was an overview of the Sure, go ahead.
Can we go back to the screen that we were just looking at?
Sure.
And then the yeah, there we go, the orchestration list. So does it read from top to bottom that the mediator request came in, and then these other activities happened, and then the response, and then it was posted to the repository?
That's right. So these read in order, and they give you, if I actually click on these, it'll give you also the full request and response that specific orchestration step that happened within that orchestration step.
So could we just return to the screen that showed them in a list like that? So here's, and I'm sorry to be, something jumped out at me and I couldn't figure out what it was until just as you were leaving the screen. So the message came in at 15:47:29, and then in the previous second, 3 things were done, and then it was posted to the repository at 15:47:29. Are there different computers or different VMs that are running, and are they all not on the same clock?
Well, that's actually quite curious. I think that's probably because there's things that are running on different systems here, so different machines. And they probably don't, their times aren't probably exactly in sync. So that's probably what you're seeing there. But I hadn't noticed that before. But you're right. They should be in order of time. This is probably just a slight discrepancy between the times of different systems.
Gotcha.
I mean, in a production environment, this would probably be you'd sync to an NTP server so that you'd always have time that's pretty much exact. It seems like that is not the case in this my test infrastructure.
No worries, and I apologize completely for being so anal that is actually the thing that jumped out at me in the face of all of the other beautiful things on that screen. Please let's carry on.
No problem. And just another comment. I mean, if anyone has any suggestions or ideas for us, we're really happy to hear it. We're looking at where we can take this tool and what we can do to change it and make it better. So if you notice something like that, or if you want to even comment offline after the call, that's fine too. But yeah, we're keen to hear any feedback that you might have for us.
When in a production environment where they are synced, what's the precision that's stored at, Ryan? Can you use that to do some performance debugging, for example?
It should be pretty accurate. I guess it depends on how often you sync with the NTP server, which I think happens fairly frequently, and it just sends like a slight, like almost offset of how far you are away from the server time, and it corrects that. So they should be fairly accurate, just depending on how.
Sorry, I meant to say what's the precision, not what's the accuracy. I misspoke. I'm looking for whether or not it's to milliseconds or something that would give you a way to profile what the performance is of various services. In a production environment, they could well be on different VMs or even different machines. It would be useful to be able to tell which calls are taking the time.
I see. Sorry, I misunderstood what you're meaning there. Yeah, I think it's all the way down to millisecond accuracy. So that should be something that you could use to benchmark and do performance analysis.
Very cool. Thank you.
Okay, so we've had a quick look at the transaction log and what you can see, but I suppose that doesn't make a whole lot of sense without explaining a little bit of how you can actually get the system configured to receive messages in. So I wanted to chat about that a little more, and hopefully that would become a bit more clear. So within the OpenHIM, some of the fundamental things that you'd want to do when getting started is create clients and create channels. Those are the two core configuration bits that would be useful. So if we go switch across to clients, what a client is really some point of service system. So you can think of this as a electronic medical record system that's sitting in a clinic somewhere, or perhaps even a lab system that wants to share information that's sitting in a laboratory somewhere, and they would want to talk up to the Health Information Exchange through the OpenHIM. So what the OpenHIM allows you to do is actually create a client, and this is really like a login, essentially, for that entire system. So it's not per user. What we're doing with OpenHIE is we're trusting the point of service applications to authenticate users, and then we authenticate the entire system as a whole. So there's that sort of chain of trust that's formed. So one of the most fundamental things you'd want to do is be able to create a new client. So what this entails is just giving a client ID, and then just setting specific roles that the clients may have. So I can say maybe it's an EMR system, for example. And you can make up roles on the fly, and those are used later to actually restrict what this client can do. Then there's two ways that the OpenHIM supports to authenticate these clients. The first is a basic authentication, which is just a standard on HTTP, which allows you to send a username and password. Not the most secure unless you're using encrypted HTTP channels. So the way that we would expect most production systems to run is actually by supplying a client certificate. So within the OpenHIM, you're able to upload and manage certificates, and we'll have a look at that in a second. But basically what you can do is choose a specific certificate that represents that client, and then whenever that client communicates with you, as long as they communicate using that TLS certificate, the OpenHIM will know it's them and authorize the request. So I already had a person named Test, so that actually failed, but that's not important. So let's have a look at that certificate page. So this is something that's actually quite new to the OpenHIM software that we've just added in the last release. It's the ability to manage certificates. So you can manage two types of certificates. One is the certificates of the OpenHIM itself, and then the other part is certificates that the OpenHIM trusts. So these would be the clients of the system. You'd trust the client certificates. What you can do here, usually you would get a certificate from someone like VeriSign or Forte or something like that. That would probably be the most secure way for a production system. And then the system allows you to upload your server certificate and key, and then it will automatically just use it. So we're trying to make it as simple as possible to get good security infrastructure up for a health information exchange.
So Ryan, sorry for interrupting with a question. Is it possible, instead of creating individual clients for potentially hundreds of systems, to simply chain to a certificate authority or somewhere in the certificate chain? So to say, for example, I have a certificate authority for all my EMRs, and I can just say any EMR with a valid certificate that's not expired and not revoked, assigned by this certificate authority, is trusted.
Mm-hmm. So that's actually something we've just added in the this version of the software, along with this certificate management tool. And actually, at your request, Justin, we added that in. So what you can do is, when you're setting up the server, I don't know if I can show this. Perhaps it'd be best to try show some of the config.
You could just talk through it, Ryan, if you're worried about getting too much into the weeds and unseating the rest of your demonstration.
Sure, I'll talk to it a bit. So basically, what it allows you to do, the default is there's a strict mode, and there's an in-chain mode that you can select in configuration of the OpenHIM server. The default is strict, and what that does is you have to have a separate client certificate for every clients that you have in the system. So that's probably the most secure way that you can manage clients, because then you can remove them easily, and that's the general way we'd probably recommend. But if you do have extremely large amounts of clients and you want to authenticate them all in one go and not have to worry about all that management overhead of managing individual client certificates, we have the in-chain option. So what that'll actually do is you can set up a single client that's somewhere in that certificate chain, and then what it'll actually do is when a request comes into the OpenHIM, it'll look at that certificate. If it can't find that certificate in its trusted certificate store, it'll look at the issuer of that certificate and try to find their certificate in the certificate store, and it sort of keeps going up the certificate chain until it could find a client that matches. And then if it does, then it's authorized. Then the request is authorized. So it pretty much allows you to have one certificate that manages a whole number of different clients, as long as as long as the clients have somewhere in their chain that client certificate. I hope that makes a bit of sense. It gets a little complicated explaining it.
It does. There's a distinction between being authenticated and being authorized. Are you also using the role, or are you not using the role? Because once I know, you can authenticate who Derek is, but then it's a separate question to say what is Derek allowed to do.
Right. Exactly. And I'll get to that in a second, Derek. So this is what I'm talking about here with certificates and the basic auth stuff is actually authentication. So we'll talk about authorization when we have a look at channels in a second. So I'll just finish off with this page and then we'll move on to that.
Yeah, and just to clarify, this is authenticating Derek's machine, and the authorization is authorizing Derek's machine to do something, correct?
Yeah,
that's right.
At a node level. Okay.
Yeah, so we don't authorize individual users. We expect the points of service applications to do that themselves. This would be authenticating an entire machine that they're allowed to talk to the Health Information Exchange. That's correct. So one other thing that we've just added with this release is the ability to actually, if you aren't able to buy a certain certificate from a well-known authority, you can create a self-signed certificate, and the HIM will actually do that for you. So we have this ability to create a server certificate for the HIM server itself, and then you can actually this is it's still secure if you do a self-signed certificate, as long as you only use it within your sort of enterprise or within your health information exchange. It won't really work very well if it's across the internet or something. But you can create your own self-signed certificates, and that's just to make it a bit easier to get set up with a sort of security infrastructure, and not have to worry about paying for certificates. Especially this, I think this will hopefully help in some low resource settings, and as well as creating a server certificate, which is for the OpenHIM server itself. You can create self-signed client certificates as well, so for example, if we had new systems coming in, we could create certificates for them on the fly, and then they could use those. So what this basically means is the OpenHIM tool can act as a certificate authority for a health information exchange, and that helps you, especially when we consider that we're relying on some of the IHE profiles. This helps get us pretty far along the line with supporting ATNA pretty easily. You don't really have to do anything too much. You don't have to know too much about security infrastructure to get a certificate created using the OpenHIM tool. So that's something that we also support. Okay, so now I'll move on. Now that we've talked about clients and certificates, and that's how you can actually get a system to be authenticated with OpenHIM. The next important thing is, well, what then? Where does the message go once it's authenticated? And that's where the concept of channels comes in. So you can see I have a whole bunch of channels in my test system, and this is really the major configuration piece of OpenHIM. So let's I'll just click create a new channel and run you through what can be done. So basically what a channel is when a message comes in, the OpenHIM needs a way to determine what to do with it, where it should send it. So should it send it to the shared health record? Should it send it to the client registry? Should it send it to a mediator? That's what it needs to know. And the way it does this is primarily by looking at the URL of where that message was going. If it's a HTTP type message, it'll look at the URL, and you get to specify a specific path. So you can say, for example, / shared health record, for example, SHR, and then configure this channel so that anything that comes in with / SHR in the URL will be sent to the shared health record. And we support HTTP as well as just normal TCP sockets for some of the older messaging standards like HL7 version 2. And then we also support what we call polling channels, and this is when point of service applications don't actually send messages into the OpenHIM, but the OpenHIM triggers something to happen. So if, for example, every 1 minute, the OpenHIM itself will send out a request and say, okay, something needs to do some work. So for example, we use this within OpenHIE to trigger a refresh of the OpenInfo man. So we can have a polling channel set for every, say, X amount of minutes to send out a request to the OpenInfo man and say, you need to refresh your cache, or you need to merge patients or something. So that's what that would be used for. And now getting back to what Derek was asking about is how do we do, we've got authentication, how do we do authorization? How do we determine that someone has the correct authority to actually get a request, to send a request to a system within the Health Information Exchange? And this is this next tab that we have, access control. So remember when I showed that where we set up a client, we set up them with a specific role. I think I added it as test or something like that. So what we're allowed to do here under access control is specify the roles that are allowed, or the specific clients that are allowed to use this channel.
And this is how we do it. You use EMR as the role.
All right. So, for example, you could use EMR here as well to restrict the role to just that client, or any client that has EMR as its role. So that's how we do authority. There's a few other things that you can do here as well. The main one is this top one, so the allowed roles and clients. These other few you don't have to actually use unless you want to do further restrictions. But what it allows is the people that actually log into this console are able to view quite a lot of detail about the transactions that happen for a specific channel. So they can view the full request and response body for a specific transaction, and sometimes they contain sensitive information. So what we've also got here is our access control rules to control what sort of content we can actually show to people. So this is actual people that are logging into this administration console and managing the OpenHIM. We can say that they're only allowed to view this channel's transactions, or if they're allowed to view this channel's request and response bodies, or if they're allowed to rerun transactions, because those are three fundamental things that you might not want to allow. So firstly, you might want to not allow people to, everyone to have access to some of the clinical data channels that you have, for example, where they could see quite a lot of a patient's clinical information. So you might have certain users that are allowed to do that and certain users who aren't. And then the same goes for being able to rerun a specific transaction. So I'll talk about rerunning in a little bit, but basically what the OpenHIM allows is that if a transaction fails, you're allowed to rerun that transaction. And that means the point of service system doesn't have to do anything more. They don't have to rerun the transaction themselves. The OpenHIM tool can someone can log in and actually rerun that transaction. And what it'll do is just send it again to the Health Information Exchange infrastructure, or wherever it was being set up to send that message to, just to allow you to rerun failed transactions and things like that. Okay, so the next bit that we have is some additional ways to match, to do content matching. So for example, if in the very basic section we just set a URL pattern of /shr to match that. If a message comes in on /shr, it should match this channel, and then we'll do something with it. Content matching sort of takes that one step further, where we could either match specific content types in the HTTP headers. We could do regex matching, so we can match something that's contained within the body of a message. Could do XPath matching for XML requests. So if we have if a specific element exists in an XML message, then we can match this channel and do something with it, and also JSON matching. So this is just more advanced ways of making sure that only the correct messages get onto this channel and are sent to the right place. But I won't spend too much time on that. The next and one of the most fundamental configuration options is routes. So what a route is now you have a channel that can accept messages from a specific path, like /shr, like we filled in just now. And routes are what's actually going to do with that message? Where's it going to send it? So routes are basically where we're going to send that message to. So you have a whole bunch of different options. You can set a route name. You can give it host name and port numbers of where you actually want to send that message to. You can specify a specific path to use, for example, and specify basic authentication if we need to as well. What we can also do is, if this is a secured route, you can see here I chose secured true, you can actually choose one of the to use one of the certificates that we have in our store. So we expect that the person we're sending it to have a specific certificate. So that's even more, just to make it more secure. So that's basically what we do. And you can have multiple of these. You can have many routes. So for one message that comes in, it could either go to one other route, or it could go to a list of different routes. And then we have what we call the primary route. The primary route is the one where we actually capture its response and send that back to the point of care system. All other routes, we still capture their responses, but they aren't sent back to the client. They're just stored in the OpenHIM console so that you can view them later. Because we can obviously only send one response back to the client. So that's the concept of routes. Does anyone have any questions about that? That's quite an important step, I guess.
Do you have a way to specify the order in which they go, in case that's important?
No. So for efficiency, they'll fire asynchronously. So they'll all go basically the same time, just so that if you have one slow route, it doesn't actually slow up the whole system. So in theory, these shouldn't matter, the order in which things happen. Okay. If you wanted something where order matters, the best option would actually then to create a mediator, which is a separate little service which will then manage that order and make sure things happen where they need to.
Gotcha. Thanks.
Sure. Okay, so then moving along, the next important thing that you can do with a channel is add alerts. So this is quite cool, and we use this on some of our production systems. So you can add an alert. So say what that does is if we get a certain status back, like say you get a 500 status back, and then you can send an alert, an email alert or an SMS alert out to people that should be monitoring the health information exchange infrastructure. And they'll get those alerts and be able to look at what the problem might be. So obviously, errors do happen. So you don't necessarily want to be alerting people for every single one, although maybe you do. So what we've also included is a failure rate. So if there's within a certain polling period, I think we use about a minute or so, it'll poll the database and see how many transactions have failed. And say if you're starting to get about 10% of transactions that are failing, which is quite a significant amount, then it'll alert whoever needs to be alerted. So that's quite a cool feature that we use just to be able to monitor what's actually going on within the health information exchange. And you can add individual users to get alerts, either via email or SMS, or you can actually add an entire group, what we're calling contact lists. So you can have a list of common contacts that should be notified that things are going wrong. So that's quite a nice feature that we've been using. And then these are just some additional settings. We also allow you to either choose to store the request and response body, or you can turn those off if you like. Those are on by default because it's very useful to have the request and response body. But we had some cases where people were sending some really massive requests through the OpenHIM and weren't really interested in seeing what those were after the fact. So they were running out of disk space very quickly because all of the we store pretty much everything, all requests and all responses. So we gave that. This just allows you the option to either turn that off if you so choose. Okay, and that's basically channels. So now we've got, if you set up a client, you link it to a channel through the role, the client's role. You're now, when you send a message in, the message will be authenticated to the system that actually sent that message. We'll make sure that there's a client that exists that's for that system. And then once we do that, the message will then be inspected, and we'll see that we'll try to find a channel that it matches. And if it matches a specific channel, we'll check that that client has the authority to run the message through that channel. And then once all that's been determined, we'll actually send that message on to any routes that the channel has. And that's sort of the basic flow of what the OpenHIM does. I have a few other things, quite a few more bits and pieces to talk about, but I wanted to pause here and just see, does anyone have any questions about that in general? Because that's sort of the crux of what the OpenHIM does.
Ryan, is this, I mean, I know this to be a health information mediator, but it looks like it could be generically used for all kinds of things besides channeling health information messages.
Yeah, that's right, Derek. I mean, there's nothing really tying it to the health domain too much. The one thing, there are some peculiarities, like in channels we can, if I just have a look here, we do have the concept of, in routes we have an MLLP channel, which is not really used outside of HL7 version 2. So that's one peculiarity. Another is the fact that we support ATNA audit logs, which I'll get to in a second. Those are generally, used by IHE profiles. But you're right. I mean, those are all optional things that you don't have to use. So this could be useful in a number of different scenarios. Probably for in any sort of service-oriented architecture where you'd want to have something to do security and things like that.
I appreciate we're down to the last 13 minutes, and I don't want to stop you from getting to mediators because I'm especially keen to see that myself.
Sure. So now let's move ahead then if there aren't any other questions. One thing I wanted to touch on, I'll probably touch on pretty briefly just to give you an idea of, is tasks. So as I said before, you can actually rerun certain transactions. And what will happen is it'll create a rerun task. And you can see a list of these, what's been rerun, what's the status of, like, for example, this one, I reran 5 transactions, all of them failed again, so there's obviously something else I need to do to get those to pass, and things like that. So this basically just shows you what's been rerun and what users have rerun before. But I won't spend too much time on that. Right, so the next important bit to talk about is probably the audit log. This is something brand new to the OpenHIM tool as well. We now support ATNA audit logging. So this is an IHE standard for doing audit logs. And we have, so the OpenHIM now acts as an ATNA audit repository. It can support messages that are either UDP or TCP or TLS types of admin messages. And it basically logs all these messages. If I view one of them, you can see the details. It extracts all the details from that audit. It tells you the participant objects and active participants and various things that are encoded within an audit log. It also, which we try to design this to be pretty robust. So at a minimum, it'll always store the raw audit message that it gets. So if it fails to pass out all these additional details, it'll at least have the raw message, just so that we don't lose anything. I think losing audits would probably not be a good idea. And that's basically it. You can search for a whole bunch of different filters and parameters to get back the audits that have occurred. But for now, I think the important thing is that we have an audit repository within the OpenHIM, and that'll be quite useful for OpenHIE as a whole as we start to use a lot of the different IHE profiles.
Ryan?
Yep?
Something you just said struck a chord with me about how important audits are. And can I ask, what's the how durable is a particular transaction that is underway? And by that I mean, if the HIM crashes, what does it do with its last dying breath in order to give it the ability to be restarted? Or if there was a transaction that was halfway through, when it restarts, does it finish it? That kind of thing.
Sure. So that's the HIM won't be able to pick up a transaction that fails halfway through. But generally, we do have a bunch of different ways in which that can be optimized. So one thing I haven't spoken about is that the HIM can be clustered, not only between a whole bunch of different servers, but also on the same machine. So for example, if I ran the HIM on my laptop here with clustering turned on, because I have 8 cores in my machine, it'll run 8 processes of the OpenHIM, and each of those will basically share the load of requests coming in. So what will happen if one of those workers actually died, it would basically just be respawned in probably a few milliseconds, but in the meantime, all the other workers will take on the jobs that one would have been responsible for.
Is a unit of work treated as a do we have ACID properties on a unit of work? Is it transactional in that regard?
I don't think you could say it's fully like ACID compliance. The database we're using is MongoDB, and we are doing acknowledgements on writes that we do, but I don't think we'll necessarily, if something failed halfway, it wouldn't roll it back. We'd still keep the state that transaction got to a processing state and failed, which I'm not sure if we'd actually want to necessarily roll that state back, but rather have something in the logs that says we got halfway and this is where it got up to. So it gets a little interesting as you start to think about those sort of things.
Right. Well, especially since we are in the health domain. So depending on what the state of a patient record was at the halfway point, you're right, it would be useful to know, so that you could make sure that there was nothing, that there were no safety issues that were at the halfway point as opposed to at the full on or full off.
Mm-hmm.
But exactly. You get that. You could discern that from the logs, right? A detailed because we're storing every step in the orchestration. We could always figure that out, right?
Yeah, that's right. So you can see where it got up to, how far things went. That's just the general idea.
Gotcha. Thanks, Ryan.
Sure, no problem. So I could start to move a little bit more quickly as we run out of time. I'll move on to mediators. I think that'll be the last thing we tackle. But the one thing I wanted to show as well is what we call the visualizer. And this is something we borrowed from what the Mohawk team had done previously. So what we have here is basically you can configure within the OpenHIM config how you want the visualizer to look. And for example, here I've just got a very basic one with the you can see the OpenHIM is always sort of the middle piece, and then you can have the different routes or the different channels that, sorry, not routes, these up top here are the different channels that can get activated when a request comes in. So you can see actually where it's going. At the moment, what we can't do necessarily is show all the little bits of orchestration pieces that are happening. So for example, in my current example, I have a request go to the MHD to XDS mediator. This is something I'm busy building at the moment. That mediator does a whole bunch of stuff and sends the message out to a bunch of different services. We can't model that one level up just yet, but I think that's something we'd want to do in the future. But we can at least see which routes it's going to at this point. So I can actually show you what that looks like. Hopefully this will work. So I'm not sure if everyone saw, it should have lit up in the background. I had my screen covered by something else to run that. I'll run it one more time and hopefully we'll see that work. So that'll basically show where the request is going, what components are getting activated within a health information exchange. And it's pretty useful for just seeing what's actually happening and giving people an idea of what's happening under the skin of a health information exchange. Okay, so moving on to mediators. So mediators are the last little bits that the OpenHIM supports. There's not too much you can show from the console side of things, but I'll basically talk through what mediators are. So the way we've designed the OpenHIM is that it really does, the core does a few things. It does security, it does logging, you can view all the past requests that have happened within the OpenHIM. It does authority, those sort of things. When you actually want to do some more complex business processes like orchestration, so orchestration being the execution of some arbitrary business process for a specific purpose. So, for example, resolving a patient's identity, resolving a provider's identity, and then enriching the original message and sending it onto the shared health record. That's quite a common one we do within OpenHIE. That would live within a mediator. So mediators are actually completely separate little services that you can write in whatever language you choose, but we provide some frameworks for both Java and Node.js to get people started on writing mediators. And what mediators do are basically execute that bit of extra work that you want to do, which can either be transforming a message from one type to another, or orchestration, as I just mentioned. And we've defined a framework or an API that the mediators use to communicate back with the OpenHIM core. And that allows them to give us more detailed information about what they actually did and what happened during that request. So we have a Mediators tab, and this basically just shows you what mediators are currently, that the OpenHIM core currently knows about. So mediators, as you run them, as they come online, they're required to register themselves with the OpenHIM core. And this is the type of information that you get. So you get an identifier for that mediator, the mediator's name, the version of that mediator, and any endpoints that mediator has. So endpoints are being where the OpenHIM core should send messages to for that mediator. So we have that sort of information there. And then another important bit that also gets sent across when a mediator registers itself is a default channel config. If you if a mediator has a default channel configuration, it'll actually create a channel for you within the OpenHIM core. So, for example, let me just find one. For example, this MomConnect MHD channel here, that was actually created by the mediator that I'm currently working on. So it can actually set up some initial configuration for you and to get you going. Obviously, you could go in and change this if you wanted to, or you could choose not to use that channel and disable it. But it gives you some initial configuration just to get you started with that mediator.
If you disabled the default, Ryan, how would you connect it to another channel?
So then you could just go into any of the channels. So for example, I just chose this one. Under routes, you can see you can either add a new route through this button here, or you can say we can add a mediator route. And you can see this, because when we get information from the mediators, they send their endpoints where you can contact them on. What we do is we can pull that information out and create a route out of it.
Gotcha.
So you can see here I've got the MHD to XDS route. So this will very easily just enter in all the config that the mediator sent us about where it lives and what port you can contact it on. You could also set that up manually if you knew that information, but it gives you the easy option to just, choose a route that already
any
exists.
mediators that have been registered with the core, you have this. It populates the drop-down for you.
Exactly. Yeah, that's
fantastic. Right. Thank you very much.
Sure. And so I suppose the interesting thing to come back to is so now that they've registered themselves, what can they do that's more exciting? So, because generally mediators will be doing some other complex logic and things will be happening, and you'll probably want a view of that. And that's kind of what we touched on when I first started. So within a transaction, you'll start to get, under the response, you'll see all these orchestrations. And what actually happens behind the scenes is the way we've defined the mediator framework is that whenever a mediator responds back to core, so when the core sends the mediator a message, the mediator does something, and then the mediator responds back to core with its response. What it does is it actually wraps its entire response in this extra metadata that also tells the core what orchestrations it did, and whatever other information it might want to tell it. And generally, these would be a list of orchestrations which contain requests and responses for calls that the mediator made, the time that those took, the status of those, and there's also some additional properties that it could fill out for any sort of unstructured data that the mediator might want to report back to core. So for example here, so the structure that I have going on in my tests at the moment is I actually have two mediators. I have the OpenHIM core, which if we look at, maybe this diagram will help us explain it a little more. So we have the OpenHIM the health information mediator. So this is the HIM, the core, and then I have this XDS to MHD mediator sitting above there. But then above that, there's actually another mediator that's not shown on this diagram, and that's an XDS.B mediator. So what's actually happening in that request that I was looking at there is a request comes in to the OpenHIM core. We do all the authentication and authority stuff. It then gets sent on to a channel that sends it to this MHD to XDS mediator. And that MHD to XDS mediator converts the message that it's receiving from an MHD format to an XDS format, pretty much what its name implies. And then what it does then is it actually forwards that request to another mediator, which does some other processing. So then that mediator receives that request. It then does a resolution of a patient identifier, resolution of a provider identifier, resolution of the facility ID, and it does all that by reaching out to a client registry, a facility registry, and the provider registry, and then it finally sends that off to a shared health record. and the shared health record then responds saying that that message has been successfully saved, and that goes back to the XDS mediator, who then compiles all the orchestrations that it did, adds that metadata onto the response, sends that to the MHD to XDS mediator, which now receives this big response with all the orchestrations. It adds in its own orchestration that it's done, and then returns all that metadata back to core, who's able to store that, extract the response from the shared health record, and send that back to the point of care system. So I know this starts to get into sort of more advanced topics and can get confusing, but that's basically what it does. And then what we use that information for is to give us a good view of what actually happened within the mediator. So you can see we have the MHD to XDS mediator orchestration here. So if you inspect this, we have the request that it made out, that mediator made, and the response it got from the XDS mediator, so the mediator above it. And then these are the 4 orchestration steps that the XDS.B mediator did. So it passed the contents. There's nothing really to view in that. It just reported that it was able to pass that message. It then did a resolution of client identity. You can see the HL7 version 2 messages that were sent for that to happen. It then did another resolution of identifiers. There's probably 2 IDs for this patient. And then it finally sent it on to an XDS repository, which is the shared health record. And you can see the request and response that we received from that. And those are all then captured there so that we have a log of what actually happened throughout the health information exchange and that whole workflow. Okay, so I mean that's basically it for mediators. I hope that makes a little bit of sense. But if you want, please ask any questions that you might have.
I don't have any. Thank you for answering mine along the way. I apologize, but I've got another meeting that I have to join in progress.
Yeah, sure. Well, sorry.
Very nicely done.
Oh, thank you, and sorry for running over time. I see we've lost a few people, but yeah, just thought I'd get it going anyway. All right, thanks everybody.
You've shown us a great deal in a short period of time. I think that this is something that warrants more exploration and more explanation. And thank you so much for this.
Sure, no problem. And thanks everyone for joining. I'll end the call today, seeing as we're already quite a few minutes over.
Thanks, bye.
Great, thanks all, bye.